In 2003, the automotive world relied on a single, unquestioned standard. This internal combustion engine represents over a century of metallic refinement, yet it remains a system that depends entirely on fossil fuels and constant carbon emissions. Early attempts to build a battery-powered alternative were characterized by heavy lead-acid cells and limited utility. These vehicles were slow, boxy, and lacked the performance needed to appeal to anyone outside of a niche group of enthusiasts. Tesla's founders recognized a structural problem. The transition to sustainable transport required high-performance lithium-ion technology, but the global infrastructure to charge those cars, and the factories to build the batteries, simply did not exist. The legacy auto industry was ill-equipped to solve this. By outsourcing roughly 80% of their components to third-party suppliers, traditional manufacturers had surrendered the ability to execute the rapid, top-to-bottom innovation required for a new energy platform. Creating a successful electric car required more than a clever design. It required an entirely new industrial architecture. Elon Musk's strategy followed a specific sequence: build a high-cost, low-volume sports car to generate the revenue and expertise needed to develop progressively more affordable vehicles for the mass market. That first step was the Roadster. It hit 0 to 60 in under 4 seconds, providing the proof of concept that an electric vehicle could be both high performance and a desirable luxury product. Moving toward a passenger sedan required a complete rethink of vehicle geometry. Instead of fitting batteries into a traditional engine bay, Tesla designed a skateboard chassis where the battery pack sits flat along the floorboards. This architecture moved the vehicle's weight to the lowest possible point, creating a center of gravity that improved handling and safety while opening up more interior cabin space than any engine-based competitor in its class. Tesla turned to vertical integration to solve a total lack of existing EV infrastructure. They realized that to sell the car, they would have to build the entire world around it. To eliminate range anxiety, Tesla built its own proprietary solar-powered supercharger network along major highways. This allowed drivers to recharge in minutes, making long-distance electric travel a practical reality for the first time. As production scaled, a second bottleneck emerged. There simply weren't enough lithium-ion batteries being manufactured globally to meet Tesla's long-term demand. The response was the Gigafactory, a massive centralized hub for battery production. By controlling cell manufacturing in-house, Tesla aimed to drive down costs by 30% through sheer economy of scale. This closed-loop philosophy reached the factory floor, where Tesla used highly versatile robotics to perform multiple assembly tasks. This allowed them to modify production lines quickly, without waiting for external equipment suppliers. Controlling everything from battery chemistry to software updates allowed Tesla to innovate at a speed that traditional manufacturers, hampered by slow-moving suppliers, could not match. While competitors spend billions on advertising every year, Tesla spends zero. They rely entirely on their product and their mission to generate organic demand. They also bypassed the traditional dealership model. Legacy dealers generate the majority of their profit from internal combustion maintenance, oil changes, and engine repairs, services that electric vehicles almost entirely eliminate. Tesla opened its own retail galleries and simplified the buying process through direct online ordering. This ensured the customer experience was controlled entirely by the manufacturer, rather than a middleman. Controlling the point of sale was a necessity. The existing retail system was financially incentivized to keep the public buying the gas-powered cars they were equipped to service. Historically, corporate leaders viewed green innovation as an economic drain, a set of expensive practices companies adopted only for the sake of public relations. This chart shows how Tesla challenged that assumption. From 2020 to 2024, their revenue grew from $31 billion to over $97 billion. The corresponding spikes in net income prove that this ecosystem was doing more than just moving vehicles. It was generating massive, scalable profit. That capital allowed Tesla to expand into home energy, offering solar panels and storage units that integrate the entire domestic power grid into their ecosystem. By scaling these fully recyclable products while maintaining massive profit growth, Tesla demonstrated that a zero-emission industrial stack can be a vastly more lucrative business model than traditional manufacturing. Global markets are now following this trajectory. By 2025, electric vehicles are projected to capture 20% of all car sales worldwide. Legacy automakers are no longer just building electric cars. They are now attempting to replicate Tesla's entire vertically integrated model, from charging stations to massive battery hubs. This is the benchmark legacy companies are chasing, a closed-loop industrial system where battery production, vehicle assembly, and energy storage function as a single unified machine. Tesla's success proved that to dominate a changing industry, you cannot just invent a new product.
You must be willing to rebuild the entire system from scratch.